A device that complies with the IEC 61850 standard is called an Intelligent Electronic Device, or IED. This device has an information model which is perfectly organized into a tree structure with a root, which is the IED itself. This device also has a name. In the example that you're going to see, it's called EF, so this will be the name that is shown in the root of its information model. A device that complies with the IEC 61850 standard can have different objectives. An objective can be acting as a control device such that, based on a series of digital inputs and outputs, you can check the status of the field devices and act on them. Another objective may be to have protection functions. Based on specific digital inputs and output plus a series of measurements, the device checks the status of the electrical grid and performs different protection functions. To do this, a series of timers is used, depending on the hierarchy of the device in the electrical grid itself. So, a device that complies with the IEC 61850 standard may consist of what was previously done by different devices. Where there were previously some devices exclusively dedicated to protection functions and others dedicated to the control world, they are now integrated into one single device. So, to enable the manufacturer to freely organize the whole information model, the standard creates a first level, hanging the physical device from it, which is called logical device. In this way, a physical device can contain one or more logical devices. Here is an example of where a device has both a logical device for control and a logical device for protection. There are manufacturers who include other logical devices for everything involving signaling or measurement. This shows that this level in the hierarchy is a free level, where each manufacturer determines whether they are going to define one or more of the device's features, represented as a logical device. There are standards for the number of characters that they can have, or which characters can be used, but initially, there is a level of freedom given to the manufacturer. Each of these logical devices will use a whole series of functional features, either to control a switch or to protect a line with different protection algorithms, etc. These high-level functional features are called logical nodes in IEC 61850. So each of the logical devices contains one or more logical nodes, depending on the functional feature that is used by the device itself. In this very simplified example, there is a switch which is controlled by this device in the control part. Logically speaking, in a real device, the model is much bigger and will not only contain switches but also choppers, blocks, measurements, etc. In the protection part, there will be different protection algorithms including differential line, distance, overcurrent and overvoltage functions amongst others. Definitively speaking, there will be as many functional features as there are logical nodes in this device. In accordance with the standard, there must always be a logical node which will be called LLN0. Later on you will see its usefulness. Logical nodes are represented with a blue background to show that they are names which you can't choose yourself, unlike logical devices or the IED, where you are almost totally free to choose the name. Logical nodes on the other hand will always be composed of 4 letters plus a number. The 4 letters are set by the standard and reflect the functional feature being represented by the logical node. For example, XCBR represents a circuit breaker, XSWI is a chopper, GGO is a digital input and output, MMXU is a measurement, and so on. On the other hand, given that each device can have more than one element of each type, the logical node's name has a number after it, in a range of 1 to 99 to indicate which of the switches, choppers, digital input and output groups etc. is being represented. In short, 4 letters identify the functional feature being performed by this device, and a number from 1 to 99 identifies the device's element. Additionally, there is the option for all logical nodes to have a prefix in front of the name, which will allow the manufacturer to organize the information, but this is a minimal level of freedom which is in fact not expressed in this case. As mentioned previously, when the standard is imported, all of the types that compose it are also imported. Hence, these types can already be consulted. In this example, there is an XCBR which would be a circuit breaker, an XSW which would be a circuit switch, and measurements, MMXN without a phase, and MMXU with phases, and so on. Hence, in IED Factory, you can look at different logical nodes, and, since they come with the description established by the standard, they will provide information to those familiar with the world of substations. If you look closely, you will see that these 4 letters are always grouped together with a prefix. The first letter indicates the type of logical node that it is. P, for example, is for protection, M is for measurement, X is for switches, choppers and similar items, and so on. Now you can create the first device in IED Factory, following the example in the slide. When you create the device, there are several optional fields, such as the manufacturer's name, in this case Ingeteam, the device's name, EF, and the device's version, V0. You also need an additional obligatory property which indicates the family of devices to which it belongs. This family element isn't part of the standard and instead belongs to the tool, thanks to which you can add more or less functional features. This is because choosing Modbus, IEC 6870 or IEC 61850 type devices is not the same as choosing devices such as INGEPAC EF. In this example, the tool itself proposes that the device should be called Ingeteam EF V0. This will be the name of the IED. The IED has now been created, which will be equivalent to the upper level of the graph. Next, the logical devices will be created, with the option to insert LD from the context-UL menu. They are going to be called Control and Prot. As you can see, you are completely free to choose the name, being able to enter any name, numbers, etc. Thus, the IED has been created with 2 logical devices, but you can continue to create as many as required. The next level is the logical node. Here, you can create logical nodes from scratch. In other words, types may have been created and you may have indicated that the type to create is, for example, an XCBR. This way of working is feasible. In other words, as you go through the different levels, the tool lets you create a whole model from scratch, but it would be a tedious task which would be absurd with this tool in practical terms. There was a time when this was the only way of doing it, but nowadays there are powerful tools that do it. To the standard, the first thing it precisely allows you to do is create an XCBR and an LLN0 in control, as shown in the slides. In the tool, you simply have to click and drag from the standard's LLN0 to the control's LD. The following dialog box shows that an LLN0 is going to be created. This is a very special logical node, since it always has to exist with this name. Hence, there is no option of selecting its name at the bottom. And at the top you can configure whether you want to directly use the type defined in the standard, or if you want to create a new type to reuse later. In this example, we are going to create a new type. Since it is the first type added to this Ingeteam EF V0, it must include all of the subtypes, which makes it take a little longer, but it's a task that would have to be done sooner or later. Here you can see how the physical device is created. It has 2 core devices and 1 initial functional feature which is LLN0. In the example, we want to add an XCBR or circuit breaker, which is done easily by clicking and dragging. In the docs for importing types, we need to indicate whether, in case the subtypes were common to those that have already been created with LLN0, they should be used or not. This dialog box is slightly different since on the one hand it's stipulated that it will be called XCBR, but that a prefix can also be created, for example, the prefix pre which will be added in front of the name XCBR, and an instance number. There is a certain amount of freedom when it comes to defining the LN name, but much less than previously seen with IEDs or LDs. We're not going to put a prefix, and we will set the instance number to 1. To create this LN, the tool will need to create a subtype, which will take some time but less than in the previous case. A complete IEC 61850 device has now been created with the device itself, its logical devices and 2 functional features, in this case, a circuit breaker and the generic functional feature.